just have your sound muted. Please have your video on. Again, the usual stuff. If you unless you're on the list, please have your video on or just message me. Alexandria and Aaliyah, I know you two usually can't have your video on. Besides that, please log on to Google Classroom and start the Do Now. The Do Now will take approximately 4 minutes, I think. Yeah, today's Do Now is actually, literally it's just like what your thoughts are. It's not really math yet. So don't worry about that. But please take a couple minutes to start and complete the Do Now. Awesome, thanks, Aaron. Hi, Renique, hi, Derek. So yeah, for people who just joined, just have your sound off, video on, and then go into Google Classroom and start the Do Now. And then for everyone who's completed the Do Now, you can actually complete the wake up question too if you'd like, which is if you could forget about money, what is one career you wish you could have if money was not an issue? Someone in my AP class said they would want to be a hitman. So that was interesting. Renique, math teacher, awesome. Yeah, yeah, that's really cool. I think it's unfortunate, like teaching jobs generally are like not very high paying, but yeah, I don't know. I think it's definitely it's a very fulfilling job. I know, like, so I have some of my friends are just like they graduated from college and like, you know, the standard thing, it's like just work for a company, I guess. And a lot of them make good money, but they definitely don't seem like they're very happy. So I don't know, kind of a trade-off thing. But also, I'm probably going to be one of them one day because I don't think I'm going to be teaching forever. So we'll see. Thanks, Aaron. Thanks, Christian. And then Aaliyah and Alexandra, you both want to travel. Awesome. That's really cool. Yeah. If money wasn't an issue at all, traveling would be great. Christian, musical artist. That would also be really cool. Christian, do you make any music right now? I really like music actually, but I don't know how talented I am musically actually. I've met some people who are very musically talented, so that's always kind of intimidating. Mercy, you said travel. Aaliyah, you make music too, cool. And then Christian, awesome. Do you like produce stuff like? Like beats and stuff. I have some friends that are really into like making beats. Samantha, you said you'd either travel or become a psychiatrist. Awesome. Would you want to be a psychiatrist or a psychologist? Or like, because psychiatrists, they make more money, I think. But I don't know, the idea of being a psychiatrist, because they're like the ones who actually prescribe medication. And I don't know. I feel like for me, that wouldn't be the most exciting thing. But I think being a psychologist would be cool. Alexandria, you said therapist? Yeah. Christian, you said you're working on a project to drop next month. Awesome. How long have you been producing music for? Also, I have 4 responses for the Do Now so far. So if you haven't completed that, please focus on that. Aaron, you said working alongside with Bill Gates. That's funny. Actually, that could be like Bill Gates. He is the Bill Gates Foundation, right? So he's doing a lot of like actually good humanitarian work. So if that's what you mean, that'd be really cool. Or you could just be alongside him because he's rich, and then you could probably get anything you want. Okay, so like 1 more minute for the do now. I currently still only have 4 responses. So yeah, I'm gonna need some more responses. Again, this isn't something where you have to think so hard. It's more just like, there's like no actual math involved in this. Well, there's a tiny bit, but yeah. Christian, you used to make music as a joke in like 9th grade, but I'm trying to take it more seriously. Renique, no, I'm not actually planning to compete in the pancake market. That is just, I don't know, I was like bored. Renique is talking about the exit ticket, if any of you guys are wondering. And then, cool. Yeah, I actually have an electric guitar next to me, so I mean, like, I like making music too, but producing seems like so much to learn. I don't know how like I would even start with that. But yeah. Okay, so we're at the 8-minute mark. I'm gonna just go over the other updates we have for today in class. Homework packet 2 was released last night, and it's going to be due before class next Monday. So basically, you'll get like Friday and the weekend to work on it. So it's going to be due before class Monday at, what is it, 10 a.m. Sorry, that's a terrible at sign. So yeah, make sure you complete that. I'm going to be releasing like a tutorial video. I'm not sure what to call it, tutorial video, probably tomorrow, so you have the whole weekend to look at it. What else? The packet is shorter. It's only 4 pages one-sided, so like literally if I made it into a packet, it'd be like 2 pages front and back. However, 2 of the problems are related rates problems, and we all know those can be a pain. So yes, that might be helpful to look at my video for when you're working through the related rates problems. Also, just give it your best shot. I'm grading these for correctness, yes, but like, if you put in effort and you're not just like writing whatever, like you can be assured you're not going to get too bad of a grade. So don't worry about that. The other update is that tomorrow, make sure you are on time for class. So for everyone, like I feel like everyone here today for some reason was like a couple minutes late, which is whatever, but for tomorrow, make sure you're on time for class because I'm going to be going over AP registration and we have our quiz tomorrow, which I talked about yesterday. So if you want full time for your quiz, make sure to be here tomorrow. I talked with Ms. Sladek, and unfortunately, we can't like do quizzes outside of class time. So I wanted to like just give an exit ticket that maybe you could start working on in class and then work on it after class to turn in and get a quiz grade for that. But the policy apparently is like you have to do it during class so I can monitor you, which sucks, I know, but that's the policy right now. So the quiz will be done during class tomorrow. And again, remember tomorrow is shortened periods. It's the Friday schedule, so be on the Zoom call at the right time, and the quiz won't be that long as a result of that. That is it for now. I'm going to move on now to the notebook setup. So today we're going to be tackling optimization problems. So I'll give everyone 1 minute to set up their notebooks, however you'd like. And then if you can actually, could someone chat me just to let me know, like, did you guys work on optimization problems in pre-calc A or pre-calc? Okay. Okay, gotcha. interesting. You guys are an interesting class because you never really took Calc A, which is like, I don't know. Kind of fun fact, but Calculus B in like terms of mathematical history was invented first. So Calculus B is integral calculus, whereas Calculus A is differential calculus. Like Calc A is like all derivatives and stuff like that, and then Calc B, which we haven't really gotten to yet, is all like integration. But Isaac Newton invented integral calculus first. So like I think you could learn Calc B without learning Calc A, to be honest, like entirely. But it's helpful to learn Calc A. Okay, I'll give like 15 more seconds to set up your notebooks. Okay, cool. Okay, so today we're going to be tackling optimization problems. Okay, so they're not really related, but I'm going to provide, actually, we'll first look at the exit ticket, and then I'll talk about optimization problems. So for everyone, you don't have to rewrite the exit ticket problem because you guys probably solved for that yesterday. But people did really well in the exit ticket, which I was very happy about. Usually like a certain percentage of students get them right, get like the exit tickets completely right. I don't know how to estimate it, but it's like for the exit ticket yesterday, it was like a very high percentage of people got it right. So I'm just going to run through the problem actually. Well, let's see. Actually, okay, so I'm going to run through it, but I'm going to cold call some people for like every step, like, but I'm not going to ask for volunteers just so we can get through it quickly. Okay, so Daniel, do you want to come off of mute and just tell us what your first step was in doing this problem?
So for this problem, I basically found the slope.
Gotcha. How did you do that?
So first of all, I did the derivative, so which is going to be f of x equals negative 2x.
Awesome. Yep.
And then you do f sorry, f of 2 equals negative 2, yeah, right. And now I'll give you negative 4, right? And then after that,
yeah, sorry, go ahead. So what did you do?
And then after you do the slope, you find the points.
You can keep going.
For the points, you just do f of x equals negative, yeah. So, and then you plug in the what do you call it, the 2 for x. Plus 3, yeah.
Awesome. So negative 4 plus 3, we get negative 1. So what is our actual point? When we got negative 1, but what's our point?
It's gonna be negative 1 comma 2.
Yeah, it's
negative 1. Sorry.
2 comma negative 1, exactly. So our point is going to be an xy format, right? So we're told that x is equal to 2. So we plug in x for 2 for x, and then y we solve for, right? We get negative 1. Awesome. Okay, thanks, Daniel. And then let's see, Derek, can you tell me the equation of the tangent line with our points and our slope?
Hello.
Hi, Derek.
Oh, okay. I thought you couldn't hear me. All right. It was y plus 1.
Okay, cool. And then?
Equals -4 parentheses x minus 2.
Great. Yep. Great job. And just to show everyone how we got that, we got y minus y1 equals m times x minus x1. Again, this is point slope form, right? And it's called point slope form. Sorry, cannot write. But it's called point slope form because we use a point and we use a slope to get the line. So yeah, and then we substitute in y1, we had -1, and then when you subtract -1, you get +1, and then most of you guys got this right, you just plug in the values. And then I'm just gonna fill out the rest because we have the equation now, then we just plug in, we're asked to approximate 1.9, right? So to approximate it, we literally just plug x in for 1.9. So y plus 1 is equal to -4 times 1.9 minus 2 is equal to -4 times -0.1 is equal to wait 1 second. What am I doing? Okay, sorry, I think I messed that up. So here, I'll just times 1.9 and then +8, I'm gonna get +7 if I subtract 1 from both sides. Sorry, I made this a mess. But y is equal to -4 times 1.9. I have that down as -7.6 plus 7, so it's -0.6. So our estimation using, we basically, right, we created a tangent line. We used this tangent line to estimate a different point, and our estimation is -0.6. Okay, so I think most everyone got that, so I'm not gonna give too much time for copying, but cool. Now we're gonna look at optimization problems. Just to provide some context, I would say in Calculus A, right, in Calc A, the big like FRQ questions, like there's always like continuity, differentiability, stuff like that, but those are just like concepts you have to understand. But the big FRQ questions are going to be related rates, which we already tackled, and optimization. I think optimization is much easier than related rates though. So this is harder in my opinion. But just to make this more clear, related rates, the main concept we employed was implicit differentiation, right? Because we found the equation and then we implicitly differentiated it. You don't really have to copy all this down. I'm just providing context. But related rates, implicit differentiation. In optimization, the concept we're going to use is maximums and minimums, which you guys are already pretty familiar with. You know, when you do the whole like number line and then you're like, oh, there's a critical point at like 7, and then you see like, is it negative and then positive, or like positive and then negative, positive and negative. It's the exact same concept for optimization. So that's the key concept we are going to be employing for these problems. But so actually, Damani, can I get you to come off of mute and just read out the part of this definition that I bracketed?
In optimization problems, we are looking for the greatest value or the smallest value that a function can take. For example, in the do now, our goal is to find the amount of flour to maximize our profit.
Yeah, Yeah, awesome. So we're looking for the largest value or the smallest value that a function can take. However, so this is like, you're probably thinking like, this sounds like exactly like a maximum minimum problem, right? Where we have to find the relative maximums or minimums. And it basically is. It's just that we're applying that to word problems now. So they're going to ask us different word problems. And they can definitely get more complex than just the standard, like, oh, what's the maximum minimum for this graph here? So they do, or it's the same idea. We're just finding the maximums and minimums. So I'm gonna cold call just some volunteers. So we're looking at the do now, right? And then our question was, using your intuition, how many pounds of flour do you suggest that the restaurant, I'm guessing Mi Gente, purchase to maximize the amount of money they make? How about Zakaya? Could you come off of mute and just like looking at those values, what do you think might be the maximum?
The maximum, like, I don't know. I honestly don't know.
Okay, if you just had to guess, like, look at this. So like, this is telling us like 7 pounds of flour, right? Gets us $210.
Right.
So if we want to maximize our dollars, like, how many pounds of flour would you guess that we should buy?
Well, 7 pounds of flour.
Yeah, 7 pounds would be a really good guess. So I would guess maybe 7 pounds. Right, we noticed that this increases, right? It increases up to 210 and then it starts decreasing.
Right.
Yeah, awesome. So, okay, thank you for that. Thanks, Zakaya. So that would be good evidence for our reasoning. However, it's also worth noting that it's not necessarily 7, right? It could be 7.1, right? Maybe at 7.1, it increases from 210 to like 212, right? So we're not 100% sure it's actually at 7. We're just told these singular values, right? But we don't know what the whole curve looks like. It's possible the maximum is actually at like 5. Maybe it increases way up to like 300 and then randomly goes down to 210 at 7. So we're not 100% sure, but 7 is a good guess. Okay, so now we're actually confronted with the problem, which is Joshua has built an algebraic model to help Mi Gente with their business to maximize their earnings. The formula he has developed is Rx is equal to negative 6x squared plus 72x, where R is in dollars and X is in pounds of flour. So our task is to use Joshua's algebraic model to determine how many pounds of flour Mi Gente should buy in order to maximize their earnings. Okay, so that might be a bit confusing. I would like everyone to take 10 seconds just to reread this problem. Kayla, that's a good question about whether you should write this down, and Ansel, thanks for asking that. I would say just write down this function for now, and then as long as you understand what's going on, you don't have to write down all the words, because we're dealing with the exact same like flour problem here. Basically, we're given a function now instead of just a table, so we're told what our profit is based on the pounds of flour. So I would say focus on the function and then understand that R is in dollars and X is in pounds of flour. And then I'm going to move through these questions. Some of them are more just like thought questions. So I think it's more just like, I want you to think about them. You don't have to write down these questions. We'll get to the actual math portion, and then I would want you to write down the math portion, but I'll let you know what that is when we get there. So just to clarify this idea, right? previously we were given a table that tells us, sorry, 1 second. Okay, so previously we were given a table where if we put in like 4 pounds of flour, we're told that we're going to make $192, right? Yeah, so we earn $192 if we use 4 pounds of flour to make these empanadas. Now we're given a more precise function. We're told that we can input any value. We can put in, let's see, if I put in 100 pounds of flour, right? I can see how much money I make, which I did not do the math on this, but this would equal some number, and that's how much money I would make. So we're told now with a more precise function. The question now is, using this model, right? Using the model, determine how many pounds of flour Mi Gente should buy in order to maximize their earnings. So this table here was good for visualizing it, but it wasn't precise because we don't know exactly where the amount of flours would maximize our money. But now we're given a function so we can actually calculate for that. So it's basically the same idea with maximums and minimums. So how might we rephrase this with mathematical vocabulary? Well, the Y values, right? The Y values are essentially our profit. Our profit, right? We input X and then we get out Y. So Y is our profit. So Y values will increase, then decrease, because that's how we've decided, right? So for a maximum, right? So again, you don't have to write all this down, but it's just more just thinking about it. So we've already talked about maximums, right? So let's say there's a max here. We know that the Y values are going to increase, then decrease, right? So that's going to be a maximum. And you can visualize that by drawing like a mountain. A mountain, you increase, right? Then you decrease. The slopes are increasing, then they're decreasing. The opposite of this would be, let's say it's a minimum, which we want to avoid for this problem because we're not looking for a minimum. But a minimum would decrease, then increase, right? And that would look like a valley. So negative, then positive. So we kind of already learned all of this. I think this was part of your homework packet. Like there was that one graph problem, and then I think these were parts of the questions. But yeah. So it's the same like interval idea. So how do we find that? How do we actually do that again? Like how do we find the maximums and minimums and find like what the slopes are, right? How do we like check if they're increasing or decreasing? Well, we find the derivative. It always comes down to the derivative, right? So the derivative will tell us our slopes, which can tell us if it's like increasing or decreasing. Decreasing. Right? And then Mercy asked, are we looking only at whole numbers of pounds? Well, that's the thing. So originally with the table that they gave us, we were only looking at whole numbers, right? And even then we were missing some whole numbers. But now with this function, we can look at any number. So we could find the maximum. If the maximum happens to be, let's say at 6.0235 pounds of flour, we should be able to tell through our optimization problem, like through finding the maximum. So it's not just going to be whole numbers. We'll be able to tell what the exact maximum is. Okay, so I'm going to pose the question this way now. So we have our profit. This is our profit is equal to this, right? Is equal to R of X, which we're told is equal to negative 6x squared plus 72x. Now, I'm going to give everyone 2 minutes now for everyone to find the critical point, because that's our first step in finding maximums and minimums. So take 2 minutes to find the critical point, and then once you find that, just chat your name in the chat. Find. Awesome. Thank you, Samantha. Another, I feel like I haven't been using the vocabulary critical points very often, which I realized last night. But just to remind us, critical points are points that could potentially be like maximums and minimums. So yeah, and the way we find them, I'll go over in a second. But another minute and a half. Again, if you have an answer, please share that with me in the chat. Thanks, Christian. So for everyone who's working on it, remember to find the critical points. We first find the derivative. Awesome, Mercy, great job, thank you. Okay, I'm gonna give like 30 more seconds and then I'm gonna call on some random people, I think. Awesome, Christian. Yep, thank you for that. Okay, cool. Okay, so to start us off, Reese, would you be able to tell us what you did for your first step or what you think the first step might be?
Well, I thought we should probably substitute in one of the points on top. So you go back to the top.
Gotcha, so you decided to substitute in values from the table?
Yes.
Gotcha, so that's a way you could kind of see what values are equal to, but if we're directly trying to find the maximum, we don't have to substitute in any values. So we're trying to find like maximums or mins, right? And we know those happen when the function goes from increasing, right? I'm just writing positive for increasing, to decreasing, or like decreasing to increasing, right? Does that make sense?
I'm not sure, but like I'm gonna get it once we keep going.
Okay, sounds good. here. Let's see. How about Renique? Could you come off of mute and kind of suggest what you did?
First I took the derivatives, to be honest.
Cool. So you took the derivative, and what did you get for that?
Oh, I got let me look at my paper. Negative 12x.
Yep. Is that it, or is there something else?
You mean for the derivative? Oh,
Yes,
plus 72.
Yep, that's exactly right. So we found the derivative, right? And the derivative, remember, just tells us the slopes. And that's why we find the derivative at all, because the slopes, if it goes from increasing to decreasing, as I was talking about earlier, then we know it's a maximum, right? And if the slopes go from decreasing to increasing, then we know it's a minimum. So that's how we find maximums and minimums. And that's because we need to look at the slopes. And if we need to look at the slopes, then we obviously need to find the derivative. So it's kind of like big picture of why we do that. But for critical points, your first step is always to find the derivative. And then, Samantha, once we found the derivative, what do we do with it?
After I found the derivative, I factored it by factoring out negative 12.
Okay, cool. And then let's say I factored out negative 12. What do we do with this though? Is there like, what's our next step once we found the derivative? Yeah, Samantha, do you want to continue or?
No, I want to continue.
Okay.
You would find x by setting the equation equal to 0, and then you would get x equals 6.
Yeah, so to find critical points, we always are going to set the equation equal to 0, or in special cases, it'd be undefined. I don't know if you guys remember that, but it's basically we set the derivative equal to 0 or undefined. And our solution here is x equals 6. And just to kind of reiterate, the whole reason we set it equal to 0, right, is because we want to find where this, so this is kind of pushing this point more, but when we're going to like maximums or minimums, right, we're going from positive, negative, or negative to positive, there's going to be a point where the slope is 0, right? The tangent line here is 0. The tangent line here is 0. So at any maximum or minimum, right, you'll notice at this minimum, there's always going to be a 0 slope because it goes from negative to positive. So if we're going from negative to positive, it has to cross 0 at some point. The slope must be 0 at some point. And then the slope for maximums must also be 0 at some point because we're going from positive to negative. So the maximum and minimum points will always have a slope of 0. The slope of the tangent line will be 0, right? Like if I draw any maximum, right, what's the tallest point? It's right here. And guess what? The tangent line here, the slope is 0. I could draw like any minimum. Where's the lowest point? It's probably right here. And if I drew the tangent line, the slope would be 0. So to find critical points, we set the derivative equal to 0. So we get x equals 6. Okay, so we found our critical points. Now, I'm going to give everyone another 2 minutes. We have a critical point. How do we determine if this is a maximum or a minimum? So I'm going to give everyone 2 minutes to see if they can figure it out. And if you do figure out whether it's a maximum or a minimum, please message me in the chat. Or message me whether it's a maximum or minimum, or neither. It could potentially be neither. Derek, not quite yet. So we found the critical point. To give everyone like a hint, remember we found it's either the top of a mountain, right, or it's the bottom of a valley. We know it's one of these, right, because we determined that because it's a critical point. and we have the derivative. So like, how can I use this point and use the derivative to test whether it's a maximum or minimum? Awesome. Okay, thanks, Aaron. Thank you, Mercy. Great job. So I'm gonna give everyone one more minute.
Wait, what's the question? Sorry.
So I want you to figure out, is x equals 6 a max or a minimum?
Okay.
Renique, we're actually going to do that at some point, but not quite yet, because we could plug it in, right? We could plug in x equals 6, and we're going to get a number, right? We're going to get told like maybe r equals 1,000. But we still don't know whether that's this 1,000 is at the top of a mountain or is it the bottom of like a valley. So is it a maximum or a minimum? We're still not 100% sure. So I'm gonna give 30 more seconds. And for people who answered the question already, did you guys learn like maximums and minimums? Like like it's hard for me to, because you guys learned Calc A, but like not really learned Calc A. So how much did you guys learn about maximums and minimums? And critical points and all that? Okay, Mercy said that you guys did maximums and minimums. Okay, thanks. Okay. Gotcha. Yeah. Okay. Dang. Okay. Yeah, I don't know why the BC curriculum, I feel like it's gonna be, because optimization is all maximums and minimums, so I'm surprised there. Anyway, we shall see. So Aram, do you want to come off mute and kind of talk about what you did?
So what I did was I made a number line and put it from negative infinity to infinity, and then I put 6 in the middle.
Gotcha. So you put 6, and then what did you do?
And then I put 5 in between negative infinity and 6, and then 7 in between 6 and infinity. And then I plugged in 5 to see if it's positive or negative on that side.
Yeah.
And then I did the same thing on the other side and plugged in 7 to see if it's positive or negative on that side.
Gotcha. Awesome. So we only have like 4 or 5 minutes left, so I'm gonna take us through the rest of this. But so you put in, you made a number line with 6, right? And you plug in 5 and 7. So 5, we're gonna get a positive number, right? Because we got 12. And then 7, we're gonna get a negative number. What is that? That's just negative 12, right?
Mm-hmm.
And then we know this is a maximum now because our derivative goes from increasing to decreasing. So it goes from increasing to decreasing, and we know that 6 is in between right here. And this tells us that it is a maximum because it goes from increasing to decreasing. Remember, we weren't sure. We know it's a critical point, so it's either a minimum or a maximum, right? But if it was a minimum, then we should get a negative slope to a positive slope, right? That would tells us it's going decreasing, and then it goes to the bottom of like a valley basically, and then it starts increasing. But since it's going from a positive slope to a negative slope, we know that it's a maximum. So yeah, so that's the general idea of why we do this whole number line thing, and we don't directly plug in 6. We plug in values that are next to 6. So to make that clear, Aaron plugged in 5 because it's between negative infinity and 6, and then plugged in 7 because it's between 6 and infinity. And then by plugging those in, we can tell whether the slopes are positive or negative. So hopefully that makes sense. So we are now, like, we basically solved the problem because it asked us how many pounds of flour should Mi Gente buy in order to max their earnings. Well, we just maximize their profit. We now know that if we use 6 pounds of flour, they maximize, right? Because we determined that this is a maximum. At 6, they maximize their profit. £6 of flour, they maximize their profit. So that's our answer for this part. Hopefully that makes sense to everyone. We have 2 more minutes left in class. We have another day for optimization problems. And I think the second day, it's the same idea again, but we're going to do harder problems. So that's going to be it for today. If anyone has questions, feel free to stay after class. And yeah, make sure to remember to do your exit ticket, class notes, and the big thing is be here tomorrow for the quiz on time. But you guys are free to go. Thanks for coming, guys. See you tomorrow.
So you don't substitute the values into the original equation, you substitute it into your derivative equation.
Yeah, so if we substitute it into the original equation, we're just going to get a number, right? Like I can substitute in 8 pounds, right? And then I'm told that I'm going to make like $200, let's say, right? But the thing is, that doesn't tell me, like, is this the most I could make? Like, I don't know, maybe I can plug in 10 pounds and I make even more money, right? Does that make sense?
Yeah, I just wanted to know because I substituted it into the original equation.
Yeah, I feel like that's that could definitely happen. So it's definitely you plug it into the derivatives because, again, we're interested in the slopes because that'll tell us whether it's a maximum or minimum. So we plug in 5 and 7 in this case. You could plug in literally any other number between negative infinity and 6. So you could have plugged in 0 and like 100 and still gotten the same idea. It should be a positive number and a negative number. If that makes sense?
Yeah, because I remember doing this last year. Not like the same thing, but like something similar to this.
Mm-hmm.
But we didn't really
Gotcha.
use derivatives. We used the original equation, I think. That's what I was wondering.
Gotcha. Okay, yeah, it's kind of stinks because you guys just took pre-calc and then I almost like, yeah, I'm like speeding through Calc A because I think next week we're starting Calc B. And Calc B, it's like almost we spent like a month on Calc A and that's it. So yeah, hopefully if you can recall some of this, that'd be good. But I wouldn't expect you to know it.
Thank you.
But, yeah. All right, see you, Kayla.